Hello everyone, welcome back to the good stuff we've been doing. We are continuing our theory of indices with example 3. So we are asked to simplify this expression. Well, what we'll do here is to simplify, take out the powers, bring out the like terms, and we'll be good. First of all, I would like to work the denominator first. Maybe let's just do it together, but let's do one part together. Let's say this part is for numerator. And then what do we have here? We have x to the, let me see, numerator part. So for the numerator part, for the numerator part, we have x to the third power, y squared, z squared, all to the seventh power. You'll be multiplying by y cube, z squared, x to the second power. And then we're taking to the power of 7, x z cube, x squared, y squared. So what we'll do that this 7 is going to multiply all the powers here. So this x to the power of 21, y to the power of 14, z to the power of 14. And then we still now have y to the power of 21, z to the power of 14, x to the power of 14. And then we'll now have, of course, to the 7, z to the power of 21, x to the power of 14, y to the power of 14. This reduced to, we have to add 21 plus 14 plus 14. So that is 21 plus 28, 9. And this is 4. So that is x to the power of 49. Each of them, each of the y and z, and we have the 49 power as well, because of the symmetry, the way they appear. Of course, this 14 and that 14 will appear, and then 21 will appear. So this is y to the power of 14 and z to the power of 14. Not really, is 49, sorry. So this is y to the power of 49 and z to the power of 49. So what's next is that we are going to evaluate the denominator. So denominator part here, as x is multiplying, 2 will multiply x to get x to the 14 here. And then we will now have y to the 7th and z to the 7. Likewise here, y to the 14, then it will be z to the 7, x to the 7, and then z to the 14 power, x to the 7, y to the 7 power. So all this will reduce to, bring it closer here, all this will reduce to, here we have, for each of the numerator, here y to the 7 will take out 1 y to the 7 here, we get y to the 7. 1 z to the 7 will take out 1 z to the 7 here, we get z to the 7 here. And then x to the 7 will do the same to the pair above here. I will get x to the 7 here. So what we'll get last there is, we get x to the 7 above, we get y to the 7 above, and then we get z to the 7 above. And then on coming down here, we'll be having z to the 7 here. Here we have x to the 7 here, and then we have y to the 7, of course. Now they all cancel out, everything reduced to 1. So it seems that the denominator is 1. So therefore everything will reduce to x to the 49, y to the 49 power, and z to the 49 power all over 1. So this is the final answer of all this. Looking at this question, even me, though I did not solve it before recording the video, I thought that it would be very lengthy. I even took out a cup of coffee. I thought I'd say this video is like 20 minutes or so. Well, it seems that the problem was really just goofing around. It's easier than it appeared. Okay, thank you for watching, and as usual, you can l- check through my previous videos to see my content. Please subscribe and like my content. Thank you and have a nice day.